morning. I got question 17 from Maya, and I checked. I didn't ask you to do number 17 in this homework. Maybe I wrote it on the whiteboard, but I didn't write it on Etsy. The reason for that is we're going to learn how to find the angle between vectors using an easier way. Actually, it's today's lesson. So I'm not going to do number 17, Maya. I'm sorry. But we're going to find an easier way to do it. G, you also send me question 11 and 14. Nobody else has asked for those questions. So I will do them in a piece of paper and I will send it specially for you. Okay? Today we are going to learn about dot product. Also called scalar product. Like numbers has some operations like adding numbers, subtracting, multiplying, dividing. Vectors has operations as well, defined specially for vectors. One of those operations is what we are going to learn today, which is dot product. And another operation that we're going to learn maybe in a couple of days is cross product, and that we'll talk about it later. Dot product, it's also called scalar product. It's called that because the result of this operation, the dot product, give us a scalar, a number. So the result of dot product is not a vector, it is a number. That's why it's called scalar product as well. So if we have two vectors, A and B, and I know the angle between them, and we know that when we are talking about the angle between vectors, we are talking about the angle between the tails. And I know the length of this vector, I know the magnitude of vector A, and I know the magnitude of vector B. So I know it geometrically. I represent it geometrically by the magnitude and the angle. The dot product of A dot B will be the magnitude of A times the magnitude of B cosine the angle between them. And the angle between them is the angle between 0 and 180. So we don't talk about this angle, we talk about the angle that between them, but the smaller angle. So theta is always between 0 and 180. Okay, and the result of this, of course, will be number because I'm multiplying a number by a number by a number. Cosine theta will be a number as well, so the result will be a number. Okay. If the angle is if theta is between 90 and 180, that means the angle is in the second quadrant, so the cosine will be negative. So A dot B in this case will be a negative value, a negative number. Again, if the angle is obtuse angle, so theta is in the second quadrant, cosine an angle in the second quadrant is negative. So negative times positive will give us a negative. Okay? If A is perpendicular to B, the angle is 90 degrees, theta equals 90 degrees. A dot B will equal 0 because cosine 90 is 0, so 0 times anything is 0. So if I give you any vectors and I said prove that those are perpendicular vectors, or the angle between those two vectors is 90 degrees, you just need to do the dot product and see if it equals 0. That means the two vectors are perpendicular to each other. Okay, now this is how we do dot product if represented geometrically. I told you last time that we can present the vector algebraically by knowing the Cartesian components or coordinates. Let's say we have vector A and vector B, and the components are A1, A2, A3, and the components of B are B1, B2, B3. If I want to find A dot B, I will multiply the X components, so A1 times B1, then I add it to the Y components multiplied together, then I add it to the Z components multiplied together. That's if we are given the vectors algebraically. Okay, so example, vector A equals negative 1, 3, and 5. Vector B equals 2, 0, and negative 7. We need to find A dot B. So A dot B will equal in this case negative 1 times 2 plus 3 times 0 plus negative 7 times plus 5 times negative, doesn't matter. So negative 2 plus 0 minus 35, so this will be negative 37. As you see, the result is a scalar. And from this result, we can tell something about the angle between those two vectors, A and B. We can tell that the angle between the two vectors will be more than 90 degrees and less than 180 because it is a negative value. Okay? Alright. Now, why it is very important, why dot product can be helpful? Because as that answers Maya's question number 17. We can find the angle between the two vectors by knowing the dot product. So we know that A dot B equals, if we have it algebraically, we can do the thing and like what we did last time and get negative 37. This equals the magnitude of vector A times the magnitude of vector B cosine the angle between them. And we can get the magnitude of vector A because it is the square root of x squared plus y squared plus z squared, and the same thing for B. So we can get the length here. Now, and we can get the dot product, and then we can get the angle. So cosine theta will equal A dot B divided by the magnitude of A times the magnitude of B. So theta will equal cosine minus 1 A dot B, the number we get from here, we get cosine minus 1, and we get the angle between the two vectors. Okay, this is useful to get the angle between the two vectors. All right, so let's have an example. So example, find the angle between A, which is 304, and B, which is 2, negative 1, and 3. So we know that cosine theta will equal A dot B over the magnitude of A times the magnitude of B. A dot B is very easy. 3 times 2, 6, minus 0 or plus 0 plus 12 over the magnitude of A, so square root of 3 squared plus 0 squared plus 4 squared times the magnitude of B, which is 2 squared plus negative 1 squared plus 3 squared. So this will be 18 over 5. This is 9, 14, sorry, 16. This is 9. Where is it? 14. Oh, 4 squared is 16. Sorry. 9 plus 16 is 25, so that's 5. And this is square root of 14. So I can say theta equal cosine minus 118 over 5 square root of 14, which is the same thing as 15.8 degrees. I don't have to remind you that when we do vectors, our calculators are in degree mode. Okay, example 2, and this is very important, and it's kind of test questions. One of the kind test question. Example 2, vector A equals negative 1, 3, and 4, and vector B is 3, K, and negative 2. We need to find K so that A is perpendicular to B. So in here, in this question, we have vector A and we get vector B, but missing the y component of vector B. But they give us another information that will help us find K. What is that information? That A is perpendicular to B. So I say, because of A is perpendicular to B, therefore A dot B equals 0. Then I do the dot product, and equate it to 0. So negative 1 times 3 plus 3 times K plus 4 times negative 2 has to equal 0. So negative 3 plus 3K minus 8 equals 0. So 3K minus 11 equals 0. So K equals 11 over 3. So that means this, if K equals 11 over 3, and these two vectors will be perpendicular to each other, make a 90 degree on each other. Yeah. Okay. This is another thing. Okay. Now I still have like 2 minutes, so I will give you some properties. The first property is, if I have A dot B, this is the same thing as B dot A. It doesn't matter which one is first. So commutative property. If I have P dot R plus Q, I can add the R and Q and dot it with B, or I can distribute vector P dot R plus P dot Q. This is called distributive property. The third property is associative. If I have K scalar times K dot times vector P dot Q, this is the same thing as K times P dot Q, the same thing as P dot K times Q. So it doesn't matter, this is associative property. So it doesn't matter the scalar is multiplied with which vector. I can do the dot product and multiply it with K. I can multiply the scalar with Q and dot B dot that. It doesn't make a difference. Another thing, if I have P dot P, this will be the magnitude of P squared. Why? Because P dot P equal the magnitude of P times the magnitude of P cosine the angle between them, and the angle between the same vector is 0, and cosine of 0 is 1, as all of us know. So that will be the magnitude of P squared. Okay, I am done, and we'll continue in the next speech.